Anna Galster is a PhD student at Utrecht University, close enough, in the Netherlands, and TNO, which is the Dutch Organization for Applied Scientific Research. She studied psychology and environmental sciences. Her PhD is on incorporating human behaviors into energy systems models. And the PhD is part of a larger project to improve the capability of energy systems models. Next to the behavioral aspects, the project targets computational power, spatial aspects, and material aspects in energy system models. So, thank you, Hannah.
Yeah, thank you for this introduction. Yeah, I'm excited to be here and give a bit of an introduction on energy. So we had already Mike talking a lot about the social aspects and why the social parts and the behavioral parts are so important. So I want to bring that a bit back to the energy system models to talk about, okay, what are these models, just to have a baseline, which if this is your field, maybe that's something that's already very familiar to you, but just to bring everyone on the same page and then to see how can we connect basically what Mike said about all the different behaviors, how do we see that in the energy system model, so how can we bring that in? But just a bit talking about the energy behaviors just as a start, I was wondering, just because I'm curious, could you raise your hand if you have a flexible energy contract? So that is that if you use your energy off peak, you pay less for your energy. Yeah. Okay, interesting. Have you installed solar panels on your roof? Okay, few people have. Have you installed a heat pump? Okay, nice, good job. Do you drive an electric car? Anyone? Okay, nice. And do you actively try to reduce your energy use at home? Thinking about it actively. Okay, most of us do, yeah. Interesting. So yeah, obviously energy behaviors are so broad, and Mike has given a really nice overview of how can we think about behaviors in the energy transition in the energy system. So these are also just examples of concrete behaviors which do affect the energy system. So we want to see which people or why do people install solar panels, because that obviously means that they can generate electricity that affects the whole system. So we want to be able to anticipate that and to plan for these kinds of behaviors. So I want to give you an outline on what are energy system models, just a very broad outline, nicely, David yesterday has given already a nice overview of different modeling tools. So a couple of things will come back. Then why should we actually include social and behavioral aspects in models? We've already learned how important these aspects are, so I'll just go over this very briefly. Then I want to walk you through some of the main challenges that I see from my research and just from the research in the field. And I just want to give you a couple of examples what is being done. So how does research try to address these challenges or talks about these challenges? And then what should we do in the future? How can we move on from where we are now? So what are energy system models? So Mike has already shown you the nice Sankey diagram. This is also just another very simplified. So the Sankey diagram was more showing the European flows. If you think about the energy system in a very simplified way, you can conceptualize it like this. You go from extraction to conversion to transport, storage, and distribution, then end-use conversion and end-use. And if you look at energy system models, they typically incorporate these different aspects, and then of course in a lot more detail with splitting between different sectors, including lots of technologies, but this is kind of the baseline to represent the energy system. And maybe that's a good point also to say that I'm working with energy system models, but I am not, I wouldn't call myself a modeler. I'm more someone approaching this from a social science perspective and working on making these models, bringing these models to you. So just a heads up that you know that. Then if you look at the energy system world, there's a couple of distinctions that you can make how to conceptualize these different models. I think one important distinction, so first, that's actually good to say. So the models, they give you a path towards the future. So we want to use these models to explore how can we transition to a low carbon energy system. And then if you think of different distinctions of energy system models, one that was already mentioned also yesterday, they can be either descriptive and explorative. So they can offer like a really like, this is how the energy system is. And if we implement these policies, this is what will happen. And then you have another type, which is more prescriptive or normative. So for example, we want to bring down emissions. We want to go to net zero emissions. If we want to reach that by 2050, what kind of paths should we take? So that's not so much about exploring, but that's more about like having a norm, having a goal, and then seeing how can we get to this. Then there are a couple of other distinctions which can be useful. So one, of course, the energy system models, they vary a lot in scope. They can be really global. Then we talk about integrated assessment models. Maybe some of you have heard this term. They can be national, they can be regional. And of course, the larger you go in the scope, the less behavioral detail or the less detail in general you can include. So if we talk about these like global models, then the possibilities for including different behaviors, the different behavior of nations. Maybe it's more of a cultural thing, but you cannot, like, it's harder to go into detail as of like what are the different households doing if you're talking about a global model. And then another distinction is optimization versus simulation. Maybe some of you've heard about this also, that either you optimize towards a current state, so you want to have, for example, a transition that has the least costs for the system. So it's really like this optimal view, like how can we bring emissions down while saving the most costs possible? And another type would be just to simulate. So that would be like we don't want to optimize towards a state, but we simulate, we explore what will happen and what will be the costs if this happens. And then agent-based modeling, that was also mentioned yesterday already. So that is basically like just having different agents in a model which interact in some way or another. And that can be, I put it kind of in the middle because it is technically more of a simulation, like these agents interact and something happens, but agents can also have cost optimizing strategies. So then you again get into the optimization. So that's why I feel like it's a little bit in the middle. Then if we talk about energy system models, why are they so important? Because they are hugely used in policy. This is just an example from the UK, from the UCL website, where they talk about the UK Times, which is a model that is heavily used for climate policy and to explore different options. And that was, for example, also used for this report, Net Zero Society Scenarios and Pathways. So it just allows to explore different pathways towards the future in which we can bring our emissions down in the energy system. We talk about the Netherlands. We have this climate and energy outlook of the Netherlands. This is basically just an assessment of, okay, this is our climate goals and how are we doing? So we're running these models to see how far are we from our goals. So from this report, we concluded that the probability of reaching the climate goal of 2030 is extremely small. And different models fed into this result. There were different scenarios, as you can see also in the text. They have a baseline projection, they have scheduled policy measures. So the models are really useful because we just have so much space to explore and we have so much range to assess what is happening and how are we doing. And of course, if we talk about the IPCC, the Intergovernmental Panel of Climate Change, they also rely on so many models to bring all their advice together and to have these ranges of what can we expect to happen if we do this and that. So that's why it's really important to improve these models, because they are really used a lot and they are relied on a lot. And then not only do the models help policy and assess policy, there's also this kind of interaction. There's a nice article by Diana Sisser and her colleagues, which I wanted to tell you about. So they have here just a policy cycle. So you go from agenda and target setting to policy formulation and adoption, then to implementation and evaluation. And in their article, this is obviously very simplified, but just as a conceptual way to think about it, in their article, they show how energy models are actually relevant in each of these steps. And also not only informing policy, but also policy can inform in certain contexts these energy models. So they were looking at different European projects where they've used energy system models. And what could happen is, for example, that policymakers would say, hey, we're specifically interested in this technology, but we don't really want heat pumps. We are not so interested, or we don't really want to get rid of our natural gas plant. Or so they might actually give certain requirements that say also to the modeler saying, hey, we are interested in this, or hey, you should make the assumption that this cost will go down, or you should use this data. So that's like some like multiple influence, which of course the models allow policy to explore what could happen, but also what goes into the models can be influenced by policy. So I think that's also an interesting way to think about like how there's this interaction between the models and the policy. Yeah.
Happening amongst
that really depends on the process. So you mean the data that is generated to fit in, or maybe just for online people, the question was, where do you see data generation happening in that process? So, yeah.
like next thing you would add.
Yeah, yeah.
It's where it was like primarily adding.
Yeah. Yeah, it depends a lot also on the model, because of course the model, initially the model is based on data, right? So ideally, like you have the model, you have a lot of data, and that you update in depending on the model and depending on the funding and depending on the question, you update the data. So when you start with the initial agenda target setting, you have a model that is already informed by data that helps you to explore. But ideally, of course, after policy has been implemented and you have you see the trends, then you also update your model. So I guess the data is more of like also a circular process. But yeah, what I also see from models, it really also depends on the model. Maybe there's a model that is at this point used to more explore industry option, and the industry data is really up to date, but the household data is maybe less up to date. So because these models are so broad and so big, there can also be differences in the types of sectors in the model. Does that answer your question? Yeah, perfect. Yeah, so I think it's just interesting to think about this interaction and not to only see a model as like, okay, we have a model, we inform policy, but also there's like an interaction that can happen. Yeah, so now that we know what are energy system models and what kind of different ways we have to conceptualize them and to think of their aims. So now in the current models, the behavior that is included is quite limited. There are a few examples of models which are more advanced, but most of them are optimization models. So most of them are optimizing towards a current desired state, low costs and bringing down emissions. Maybe they have one central actor, or as Mike also mentioned, maybe there's just one demand going in, and yeah, if maybe they have a few actors just to explore, but there's really a lot of work that can be done. So if we bring in social and behavior aspects in the models, yeah, why should we do that, and what could we do with it? So I found this nice cartoon. It says, with the price of oil, we decided to supplement with solar. So it just like, of course, it's a funny cartoon, but it shows that there is something is happening to the system. People are reacting, and people are not reacting in the same way, because one of them is still using oil, the other one is using solar. So you can see also differences between people. So we actually get a lot better model capabilities, because we know that social and behavioral aspects influence and are influenced by the energy system. So if we include more of the behavior as it's actually happening, and we just include more granularity, we have better model predictions and a more realistic model output. But also we account for differences in behavior, because there's not just one household actor, there's not just one actor that makes decisions on energy, but there's a lot of differences. So it's nice to capture these and to also be able to look at how does behavior actually differ. And another side of it, if we think, for example, of energy poverty, there are certain households which maybe don't have an option to make their energy, they maybe don't have an option to say, I'm installing solar panels to be more independent. I'm getting a battery, like these kinds of things, these options are not available to all households. So if we include social and behavioral aspects in models, we also get a lot better representation of the people. So that also raises attention to social aspects in the energy transition, considering these models are used so much for policy making. If we bring in the people that the energy transition affects, that raises a lot more attention to what's happening on the social side. We can capture diverse social groups and also more distributional aspects and energy justice, as Mike has already mentioned. Also, there's, of course, also a justice aspect to this. We don't just want to drive, so the current models are really focused on this technology and economic worldview, which of course is useful to analyze an energy system. There's certainly a value in it, but we are missing a lot of the social aspects that come with that. And it makes it seem, when you look at the models, it makes it seem that the energy transition, many of the models, of course not all, but it makes it seem that the energy transition is more of a technology and an economic transition rather than a social transition. And of course also affecting society. So there is another book chapter of Diana Sisser and her colleagues where they talk about what kind of role social science actually plays in interdisciplinary and inclusive modeling. So if we move away from these like techno-economic worldviews, and if we focus more on like how can we bring the social science knowledge in, we can tackle all these three aspects of energy justice. If we talk about recognitional justice, we actually recognize that the energy transition affects people, and we challenge this techno-economic worldview that is more like technologies can solve it if they're cheap enough. Then procedural justice, if we challenge the assumption and we expand the perspective and also think about participatory research, we actually really bring people's perspective into the model rather than prescribing how the model is supposed to look like. And of course, distributional justice, it can help us to understand the positive and negative aspects of the transition and how they are distributed. So as an example, if you have one household actor, then in a model, so you can see what happens to this actor that is representative, for example, of all households in the Netherlands. So you can see in all households of the Netherlands, this percent will have heat pumps. But if you would then distinguish between low and high income households, which is a very simple distinction you can make, but then already you can say so much more. And you can say in the low income households, we see a way lower diffusion of heat pumps than in the high income household. And that might, to a social scientist, sound so oversimplified, but it is already also a big step in many of the models that you can make to get more of that thinking in. Yeah. So we'd be also curious to discuss more because, of course, you have, we talked about this also before, like you have so much, like the models are so big, they have so many assumptions, and if you want to include behavior, you need to highly simplify. So from the social and behavioral science side, we know that behavior is so complex, and if we want to bring it in, we really need to break it down, and we really need to think about what are the most important aspects, what is really the thing that we want to know, and how can we capture the most while massively simplifying. So that is really a big challenge when you bring these two perspectives together. But yeah, there's a big value in doing that. Yes. So then I just found like an interesting quote of Professor Detlef van Vuuren. He's like a climate modeler for so many years and also IPCC author. And he was recently interviewed because he's the most highly cited IPCC author. So he was saying, if you're an energy technology modeler, realize that there are social scientists also looking at technology choices and that you can learn from their work and bring it into your energy modeling. So I liked how he was also emphasizing, like, you should, of course, look beyond your disciplinary boundaries, but also you can learn together. And actually together, if you bring these perspectives together, you can develop better tools, which I also think why it's so nice to have like a setting like this, where we are from so many different disciplines that we can really like discuss and learn together. And another thing that he said is making your research interdisciplinary. That's also a very important part of the work to be policy relevant. So I think that's also something really nice because, of course, interdisciplinarity is sometimes hard and it's sometimes a struggle, and you need to find a common language. You need to find ways to collaborate. There's also funding limits. So there's like so many things that are a struggle when you move towards interdisciplinarity, but that also really ensures that it's policy relevant and that the things stay up to date. And yeah, we can actually say the things we want to say. Yeah, then moving towards the current challenges of why are there not more behavioral aspects in the models? What are we currently facing? What are we struggling with? And then I want to just give you an overview of research that addresses these challenges. Are we doing time-wise? Good. So one, we discussed it also, the data availability and suitability, that's a big thing. So you don't just want to, I mean, of course, you can also just have an exploratory model where you just include a behavioral framework and you just say, I think households may be more or less innovative. So I put a household that's less innovative and more innovative. So that you can do, of course, but ideally you want to back it up with data and you want to see what is actually currently happening. And then if we're talking about national energy system models, for example, you want the data best on a national level. So you want to see how is the representative household or what are the representative households in that country and how do they act. So it's not so easy to find available data and suitable data, but I think a nice example of just a research that was done, I believe also at UCL, was using the blue energy model. So they, from another project, they had data on UK heating system replacement preferences. So they would ask, what is your current heating system and what would you like to replace it with? So what they found was that if you currently have gas heating, you are more likely to choose again gas and to not go for a massive switch of, for example, a heat pump. So that's an interesting survey by itself, but then they had this energy model. So what they did, they said, okay, from our data, we can see the probabilities of switching to a different heating system. So the probability when you have gas is very high that you choose gas, much higher than if you just do a cost-benefit analysis, and much lower to get a heat pump if you have currently gas heating. So they calibrated these probabilities and then they put it into their model to see what does the model then give and how does that differ from the cost optimal solution. So these are some things that you can do. And that's an example of data that was useful to do this. And just as a side note, I know that also in this model, I think, I'm not sure if it's used anymore, but they also have in that model a government actor. So I think that is quite nice because that doesn't assume that the government needs to be rational, but that government actor can also make irrational decisions. So that's just a side note about that model, which I liked. Yeah, so then what we are currently doing, or what I'm currently doing, like, is to quantify the drivers of households decisions. So in the Netherlands, we are lucky to have very big data sets of almost every registered household. So that makes it easier to like quantify. I will talk about this more also on Thursday, but this is like to just put a number, like we just need to know the weights, like if people have, for example, a higher income, how much more likely are they to choose a heat pump? So to really put like a quantification. So yeah, this is something that you can do if you have the data. So yeah. Then another thing that maybe we will also touch upon again is the plurality of social science theories. So if you come into that field as an energy system modeler, I remember my supervisor from physics asking me, but what's the most accepted theory in psychology? Like, just tell me the most accepted theory. I was like, it depends, you know, it depends on what you want to ask. It depends on what you want to model. It depends on the context. It depends on so many factors. So as a modeler coming into the field, and of course, then you can look at it from a behavioral economics perspective, you can look at it from psychology, you can look at it from sociology. So it's a bit overwhelming to see, oh, there's so much going on. So what do? I don't know. Even maybe my model is computationally capable. Maybe I can include all these things, but I'm like, I don't know. I'm overwhelmed. So there was a nice research done by Anne von Falkenhut and her colleagues from Groningen University. So they are all environmental psychologists, and they were collaborating with modelers and trying to see, okay, we have all this knowledge from environmental psychology about explaining environmental behavior, how can we help modelers to bring that into their models? As they noticed that a big thing that modelers are struggling with is the choice of theories, then they came up with this framework and classified different theories. So just to show, okay, if you look at past behavior, maybe you look at the habit theory, then you can distinguish social motivations, moral motivations. So just an example also of like a collaboration between environmental psychologists and modelers, and to try to help each other, let's say, in the challenges. Though when I listened to a talk of Anne van Valkengoed, she was also saying that the environmental psychology field also has some work to do in making the theories just more applicable to the models, because they are often a bit fuzzy. The links are not 100% specified. So there's also some that was, she said, also a reflection for her, for the field, to say maybe we need to also a bit change the way we have to have this discussions in the field to know how does the theory actually look like? What do we actually want to say with it? Then social science theories, yes, they are already they're ambiguous. We don't exactly know the links. We don't exactly know what is going on. So that's what I just said. Also, there's also other research that actually tackles that from looking at theories that are used in models, and then checking how do they differ. So there was a study done by Galster looking at the social identity approach. So that basically just says you have a social identity that is related to your personal identity, and that depends on the context, and there's a behavior coming out of that. So in a group, basically, you have a social identity. And when they looked at agent-based models, they found this. So the bold part in the middle is what they found in almost every model. So that's good. Almost every model included social identity. Then the black part, so the behavior, the group archetypical behaviors, they were included in most models, and the gray parts were actually included only in a few models. So even though all of these models were using exactly the same theory, the way they were implementing it and the way it came back in the model, and obviously also the results that came out of the model, were so different. So they are addressing this more from like a perspective of, okay, we know these models, we know they have these theories, so how do they differ, and how can we make that more like, what is the best way then to include this theory, and what do they say, what do they not say? Yes, then one thing that's also quite missing is the explicit guidance. So let's say you have data, you know what behaviors you want to represent, then you go to your model. How do you actually put these things into your model? So that also comes back to, I think, a big question also of that week. Like, how can we translate human behavior into mathematical modeling? That is by itself just a challenge. So how can we put a number to that kind of behavior? There was an initial article from 2019 by Evelina Trudnevite where she was just talking about different strategies to think about this. So if we go from the bottom to the top, you have the bridging strategy where you just have an existing model and you have research in social science and you just exchange. So you talk to each other, you say, hey, in my model, it's like this. Okay, my research is like this. Maybe I'm going to change my model a little bit, but you kind of more just have these like interactions and talks. If you go one step higher and also increasing in integration, but also increasing in complexity, if you go one step higher, you have an existing model and you have research in social science, and you use that research in social science to define a scenario or a narrative in your model. So based on the research, I think that there will be a social tipping point of people buying electric cars. So we want to like create that scenario in our model, put that into the model and explore what will happen. And then the highest one, which is also the most complex, is actually the merging strategy, which is also something I'm trying to do in my research, where you have an existing model and you have the research in social science and you try to actually merge. So you try to actually modify that model to really bring the social science research into your model. You end up with a structurally modified new model. So that's really this like in-depth integration that needs a lot of like forth and back and a lot of collaboration and thinking about what to do. So we are tackling this more from like a data-driven view. So starting with the data analysis, understanding how do humans actually behave, and then putting that into the model. So there's just, if you have this data-driven strategy, you can make certain like steps that you can follow. So you start with your data collection, Then you prepare the model, you calibrate and validate, and then you simulate. So you can split this process up to make it a bit more structured. You can split it into data collection and analysis. So getting that quantification out of your data that you need, having these like numbers to the different links. And then you go to the modeling. Another thing that we also try to do, because we saw that there's just so little guidance in how can we modify the models, we try to come up with concrete examples of modeling approaches. So this table is a bit small, but here these are the headers. So we have different driver categories, so pro-environmental drivers, socio-demographic drivers, all these different things. We looked at different modeling options. What could you do? Could you just include like an NPV calculation? Could you include different household groups of different incomes? And if you want to do that, what kind of data would you need? And then two things were also quite nice or useful for us to think about. Is it feasible? So if we want to collect that data, how much effort would that take? And how feasible is it? And how relevant is this behavior? So what does social science research say? So I think that's kind of like also useful for yourself to think about, okay, if we want to do that, it's probably nice, and probably some science has shown that some studies have shown that this is relevant, but how does the relevance weigh out the feasibility? So if we want to ideally go for a highly relevant and highly feasible behavior that we can include. That's a starting point for what we want to have in these models. Then something that I heard quite a bit is this perception of uncertainty and human irrationality, so that people would say, yeah, I'm a modeler, but humans, they are so random in their behavior, and we all know that like they don't make cost-based decisions. So it's just there's so much variety. I don't think they should be included in models. That's just too uncertain. Where the more I look at the models, also from an initially outside perspective, I think these models have so many assumptions. There's so many also technology learning curves, there's so much uncertainty in the models. So my response to that would be like, it should more be embracing uncertainty and saying and making your assumptions open and openly discussing. As Mike also said, if I would see a model, I would be wondering, what are your assumptions? How did you put the behavior in? So I think that's really nice to have actually a conversation about assumptions. So rather than thinking, oh, human behavior is so uncertain, we cannot put it into mathematical equations, let's just stay away from it. I think there's a really big value in just communicating about it. And then a last thing is the interdisciplinary collaboration, which has such a large value and is not always easy to do. Finding a common language, even maybe a model can be different in social science disciplines and in energy science disciplines. So even just to find that common language and to work on the problems, like maybe a social scientist will look at an energy system model and say, oh, that's impossible to put behavior in like this because behavior is complex and this is too simplified. But then also for a social scientist to understand what is needed for these models, like how much do we need to simplify, and then really focusing on what is the most relevant thing I want to represent in my model. I think that's just so useful to have this conversation and this dialogue about it. Though I realize there's also, of course, like funding difficulties and just, it might also be an initially slow process. So it might actually take some really like discussions and failures also to get to a better understanding. So that doesn't always have to be like a very pleasant process, but I think it's still really rewarding and useful out of my own experience. Then just examples of recent research. So this was our paper where like a couple of things I mentioned are in there. So if you're curious, you can have a look. And then just to show you that the field is growing. So there's recently been a lot more papers published, actors behaving badly, exploring the modeling of non-optimal behaviors, improved modeling of lifestyle changes. There's something on assessing behavioral realism in light of consumer adoption literature, overcoming socio-technical challenges, the probability of investigating climate-friendly energy technologies, modeling social aspects of the energy transitions. So you can see that there's like, and these are just examples. Of course, there's like a lot more going on. These are just examples of papers which I know I found interesting, and I just wanted to show you that there's way more people thinking about this, and there's way more people having conversations and sharing their struggles and examples of successes. So yeah, I just want to end with what, from my experience, from my project, what I think would be useful to do in the future, and how to move on from this. So as I've already mentioned, this collaboration and this interdisciplinarity, I think, is so essential, and also leads to reflections on both sides, like from an energy modeling side, like how would I need to change my model to include these behavioral aspects, but also from a social science side, to how would I need to make my knowledge, how would I need to design my studies to get the right numbers that I can then put into the energy system model. So it's like really like a forth and back. Then design behavioral studies with models in mind. So if you have that conversation also before, then you can think about, if I am collecting data, if I'm analyzing data, how can I also make that suitable for what I could put into a model? So these conversations can help. Just to try different approaches, I think is really useful. Yeah, just to trying how can we do it, and just trying out different things. And then also really important, just sharing successful and unsuccessful experiences to also learn from them, because sometimes it just doesn't work. And sometimes you have such long conversations and you just cannot agree. And I think that's also really useful to learn from and to share. One thing not to forget is also to stay close to society and policymakers, because I'm also now getting more into like having an energy model and trying to modify it. And then sometimes you feel like you model for the purpose of the model. So I think that's also something just to remember, like models are the tools, and we want to answer certain questions, and we need to bring in certain disciplines and certain perspectives to be able to answer questions more effectively or better. So I think that's just a perspective just to keep in mind and keep reminding yourself if you're more into the deeper modeling. Yeah, thank you so much, how to reach me, and also the other people like my supervisors in the project from Utrecht University and TNO